Alright, this is the 6.4a worksheet. Simplify the expression. So they want you to multiply these two. But in order to multiply them, what we're going to have to do is we're going to have to change the base on the second value here. So we'll have 3 to the 1/3 times, we're going to make 9 3 squared. The reason why we want to do that is because then we have the same base, and then once we have the same base we can use our exponential rules. So 3 to the 1/3 times 3, this is 3 squared to the 1/3, so we have an exponent raised to the exponent. So whenever you have a raised exponent, what you want to do is multiply them. So 2 times a third is 2/3. Now when you multiply with the same base, you add the exponents. So you're going to have 3 to the 1/3 plus 2/3. 1/3 plus 2/3 is 1, and 3 to the 1 is 3. And that's your answer. Number 2, write it in radical form. Well, this comes from the rule that looks like this. So if you have a base to a fractional exponent, the numerator in that exponent is the exponent inside. So it's the exponent of the radicand here. So the denominator is the index. So y to the 2/5 is going to be the 5th root of y squared. And that's it. This is the same as last time, pretty much, but the opposite. What we have here is something to the 6th power with an index of 3. So that means it's the same as this. 5xy raised to the 6/3 power, which is 5xy squared. 5 squared is 25. X squared, y squared. And that's your answer. What we'll do with this one is we're going to change these radical forms to exponential forms. So we're going to have x to the 4/2, which is 2, y to the 1/2, divided by x to the 2/4, which is x to the 1/2, y to the 8/4, which is y squared. Now when you divide with the same base, you subtract the exponents. So x to the 2 minus 1/2. 2 minus 1/2 is 3/2. Then we have y. 1/2 minus 2 is negative 1.5, or negative 3/2. So what we can do is we can take this and move it down, move it to the denominator to make it a positive exponent. And that's your answer. Number 5, we have raised exponents. So whenever we have that, we multiply them. So we're going to have x. 1/4 times 12 is 3, divided by y. Negative 3/4 times 12 is negative 9. Now if I move this up, I'm going to have x cubed y to the positive 9. Number 6, we have the same base, different exponents with division. So what we're going to do is we're going to take the numerator's exponent and subtract the denominator's exponent from it. So we're going to have 3 to the 3 plus root 5 minus 1 plus root 5. Now because we're subtracting a binomial, we're going to have to distribute this negative sign into both terms. So we're going to have 3 to the 3 plus root 5 minus 1 minus root 5. The positive and negative root 5 cancel, so we have 3 to the 3 minus 1, which is 3 squared, which is 9. Number 7, we have a multiplication of conjugates here, so let's multiply the 1 by the 1 and get 1. And then the negative 2 root 2 by the 2 root 2. Negative times a positive is a negative. 2 root 2 times 2 root 2 is 4 times 2, which is 8, so our answer is negative 7. Number 8, factor completely. Well, the one thing you should notice about this problem is that both of these are perfect squares. This is 4a all raised to the second, and this is the quantity 3b to the second. So that's your a value, that's your b value. Because what we're going to do is we're going to use this factorization. If you have something squared minus something squared, it's a plus b times a minus b. So our a is 4a, our b is 3b, and we're just going to stick those in. So we're going to have 4a plus 3b times 4a minus, whoops, it's a little messy there, let me do that again. 4a plus 3b times 4a minus 3b, and that's your answer. Number 9. Alright, so we have some inequalities, and we're going to graph them. So what I'm going to do is graph the top one first. This has an x-intercept of 3, because 6 divided by 2 is 3. So it hits here. It has a y-intercept of 2, because 6 divided by 3 is 2. And we figure that out because it's in standard form. And we talked a little bit about that in class. It's a greater than sign, and we know it's going to be greater than because the y's sign is positive. That means it's telling us the truth, that we are going to be graphing above it. And because it's greater than, we're going to use a dotted line. So we'll remember to just shade above that. Let's do the second one. X is less than or equal to -1, so that's going to be a vertical line, and it's bold because it's possibility of being equal to. So -1 is here, it's a vertical line. So we're going to have that. Put on the arrow. And then y is greater than or equal to 4. That's going to be a horizontal line that goes across 4. Now the question is, where do we shade? Remember, we're shading above the dotted line, so above here, to the left, because it's less than, to the left of this one. So that would be all of this, and above this one. So if you take all three of those into account, the area that you're going to shade is going to be right in here. So it's going to be all of this inside here. Alright, number 10. Explain what the mistake is. Well, if you remember the explanation that I went over, I think it was on number 6. We have the same base with binomials as exponents. You're going to have the top binomial minus all of the denominator. What the mistake is that they didn't distribute the negative to both terms here. They didn't distribute it to the y and the negative 3. They only distributed it to the y. That's how they got the negative y here. But if they had distributed it to the negative 3, they should have gotten plus 3 over here, but they didn't have that. So the mistake is that they didn't distribute the negative properly. They didn't subtract all of the binomial from the denominator's binomial from the numerator's binomial exponent.